Hi, my name is Troy Garner, and I'm a Crestron certified programmer in CSP. Today we're going to take a quick look at a new feature that I've added to my Advanced Matrix module, and that is automatic routing. So in the case of this one matrix switch, which is a 3x3, say we wanted to go from source input C1 and send it to D1. Well, that's relatively simple because we just need to route C1 to D1. It's a single path. So that is extremely simple. But say now we have two matrix switches oriented in the way that we've illustrated here. Now, in order to send A1 to D1, we've got choices. We can send it to the output of B1, pass through to C1, and then send C1 to output D1, or we can go through B2, C2, and D1. Now this is still not as complicated as things can be in the real world. Of course, we can have switches into other switches and loop switches back into previous switches. So now sending A1 to D1, all of a sudden we have four possible choices. We can do the same two paths that we saw before, sending through B1 or B2 and sending the outputs of the inputs of C1 or C2 to D1, or we can choose to send these outputs to D3 and loop back through the third matrix switch and go through C3 to D1. So we've gained another two possibilities because we can send either C1 or C2 to D3 and then loop back through, depending on whether we have routed through B1 or B2. So to keep things simple, what I've done is I've mocked up a very simple console application in C# to demonstrate this kind of a setup with routing capabilities. And that is this one here. So you can see we've got some graphing classes, and I'm hard coding the edges and the vertices and all the connections here. But I've got a dynamic weight that I can input from the console to D3, which is this particular node here. And you'll see in a second why that becomes important. But for now, we'll go ahead and run the program. So it's asking for a D3 weight, and the default is 1, so we're going to just type that in for now. So you can see here, it came back with 4 different possible routings, and the last two have the same score of 3, and the first two have the same score of 7. And this is ordered from highest to lowest score. So in the real world, if we were to incorporate this into our matrix controller, which we did, we would choose the one with the highest score, the very first one in this case, with some different eligibility rules as well. In that case, routing from A1 to D1 would go through the third matrix switch, which would make sense if our third matrix switch is a picture-in-picture processor and we wanted to add an image within that video frame before sending it out to D1. But if we didn't want to do that, and we wanted to send directly from A1 to B1 to C1 to D1 or C2 to D1, then we can assign a different weight to this node, which would change the score of this routing path, which goes through the third matrix switch. So let's say we give it a score of -10 every time it goes through that D3 output node. Now, the two routing paths which previously had a score of 7 all of a sudden decreased into the negatives, and that is now a score of -4. And so the routing paths that go direct from C1 to C2 to D1 have a higher score now of 3 versus -4. And we can choose the first one or the second one depending on what our needs are with our particular application. So that is exactly what I've implemented and ported into my module now, which can be imported as a symbol in Simple Windows. And you can control the automatic routing by defining a source routing key and a destination routing key and triggering the auto route digital input. So if we go back up to the top here, I've got two symbols. One is just a make string permanent, which holds these two serial signals. And you can see the source routing key is 2x2.video, and this should be changed actually. 2x2 exclamation video component of the 2x2 matrix. Input 1, we want to send it to the 3x3 matrix, the video component, output 1. The reason for this kind of obscure naming convention is simply so that we have this flexibility to define different rules and connections for video and audio components of a single matrix switch. This can also include USB, and it's simply the name of the matrix as the identifier, exclamation, subclass, which can be USB video or audio plus video or audio, colon, input or output, and then a 3-digit input or output number. Our configuration file is also changed, and we've added a few different objects and key values to different existing objects. You can see now we have a connections object array, or a connections array of objects, which define the connections from any particular output on any matrix to any other input of a different matrix or the same matrix, depending on what the application involves. And then down here we've added another key called routing weight, which only applies to the output objects, and this is, as we were doing in the console application, it assigns a particular weight to a specific output. Just like we did in the console application, where we assigned a weight of -10 or 1 in the beginning to the output node of D3 in this particular setup. And all you need to do to trigger the auto routing, this simple Windows program mocks the same 3-matrix switch setup. Is we define the source routing key as the input node and an output routing key as the destination that we want to send that source. It'll go through it, look at all the routing weights, and determine the rules for each of the routing paths to figure out which one the best routing path is. That's all. Thanks for watching.